linear search. A linear search or sequential search is a method for finding an element within a list. It sequentially checks each element of the list until a match is found, or the whole list has been searched. If the search element is found, it returns the index of the given search element, and if the search element is not found, then it returns as element is not found. The very important condition we need to remember over here is, in linear search, the elements may or may not be in the sorted order, because as it is searching in the sequentially, it checks every element present in the list. So we need not to take any pain in sorting the list for this linear search process. And the complexities of this linear search. The worst complexity of linear search is order of n. The average complexity is order of n. And the space complexity for linear search is order of 1. So this is about the linear search. Binary search. Binary search is a search algorithm that finds the position of a target value within a sorted array using mid position. The mid value is calculated with the index of the first element and last element divided by 2. So here mid is equal to first element index plus last element index whole to the base 2. Binary search compares the target or key value to the middle element of the array. If the search element is less than middle element, then search process is done on the left side of the element. Then the search process is done on the left side of the element. If the search element is greater than middle element, then search process is done on the right side of the element. If the search element is equal to the middle element, then search process is finished and it displays the position of the element where it has been found. The very important condition we need to remember over here is, the elements must be in the sorted order in order to implement binary search technique. I'll repeat once again. The elements must be in sorted order to implement binary search technique. The complexities, the worst complexity is order of log n. The worst complexity is order of log n. Average complexity is order of log n. The best complexity of binary search is order of 1. The space complexity is order of 1. So this is about the binary search technique. Let us see one example program. The next topic is searching. Searching is used to search the element in a given list of elements. So searching is of two types. One is linear search and the other one is binary search. Example program for linear search. The problem statement: to search an element to search an element from the given list of elements using linear search. So as part of linear search, the very important point to remember is, note, the elements need not be in the sorted order. The elements need not be in the sorted order. So here, as part of this code, I am using hash include stdio.h, which is standard input output header file, int main. So I'm going to initialize some identifiers. One is I want to take an array of some elements, next I for iteration, next n for number of elements, and the key element what I want to search. Okay, search element, or I can say that element as key, the key element which I want to search from the given list of integers. So I'll write here to search an key element from the given list of elements using linear search. Now here, first I am requesting the user to enter the number of elements in the array, the number of elements in the array. Scanf %d address of n. So after reading the size, the number of elements in the array, the next step is I want to read the elements, that is printf enter the elements in the array, enter the elements in the array. Now in order to read the elements, as it is a one-dimensional array, so I require one for loop. For I equal to 0, I less than n I plus plus. So here I want to read the elements. Scanf %d address of array of I. In every index of I, we are going to store the elements till it satisfies the condition, that is till n values. Now I want to request the user which element he wants to search in a given list of elements. Enter the key element to search, enter the key element to search. Scanf, I am storing that key element in address of key. Key is the identifier, right? So this is how we are going to identify, this is how we are going to use key as part of input. And from the given list, now I want to check whether the given key element is present in the list or not, for which I am going to use this for loop. For I equal to 0, I less than n I plus plus. Now I want to trace each and every element given in the list, and here the elements are not in the sorted order, so I can trace each and every element which are present in the list. Now if, let me give one condition over here. So what is the condition is, if the given array of I, is double equal to the key element, if this condition is satisfied, so I want to print the element. This is the first occurrence, we will be getting the first occurrence of the element. Okay, the given element %d is present at location %d/n. So here the first argument what I want to pass as part of this %d is the key element, the given element, whatever the key value which is there. So this will be printed at the place of %d is present at location. So I'll be getting the location from I. So here, as we all know that array index starts from 0 and the last element index is n-1. So just I want to give the accurate position of that particular value, then I'll be giving I plus 1, put a semicolon. Now after this, I am using break here. So if I use break over here, so it gives the first occurrence of the element, and wherever that first element has been occurred, so I'll be getting the first index position, and your program will come out from this particular for loop. Now imagine if this whatever the value, that is I value, whatever the I value which is there, which is double equal to the given key element, the given number of elements. If I is double equal to the given number of elements, I is equal to the given number of elements. So here I'll be simply saying that printf the given element %d is not there in the list, or not there in the given list of elements, comma. So what is that element? Key element. So why did I write this statement is, I need to give a message to the user stating that if the search element is not found, next return 0. Now let me execute this code and check whether I am getting the searched element according to its index or not. So first, enter the number of elements in the array. So I'll be taking the number of elements as 5. There are 5 elements in the array. The elements in the array, I need to enter the elements into the array. I'll be entering the elements as 10, 6, 20, 8 and 2. So these are the elements which are there in the array. Now as soon as I enter, now the control is going to this, enter the key element to search. Now I am giving the key element as 8. So 8 is present at which location? 1, 2, 3, 4. So 8 is present at 4th location. Now as soon as I enter, my output should display the given element 8 is present at location 4. The given element 8 is present at location 8. So this is how the logic whatever I wrote over here. So this is functioning accurately, right? As soon as it has encountered 8, it is coming out and it is showing me the given location of that particular 8. Now let me run with another test case and show you the element not found in the given list. So let me take 4 elements, the random elements. I'm taking random elements 33, 2, 56, 8. Now let me give 100. Enter the key element to search is 100. Now here the given element 100 is not there in the list. The given element 100 is not there in the list. So how am I getting this result is, let me show the iterations of this particular code. So first I have given n value as, first let me start from the beginning. I have given the n value as the number of elements in the given list are 4. Enter the number of elements in the array. So I have given 4. Next, enter the elements in the array. I have read all the 4 elements, that is 33, 2, 56 and 8. Now I have requested the user to give a search key. So the key element is 100. Now what is the value which is stored in key is 100. Now let us check. I equal to 0, I less than n. What is I value? I value is 0. Is 0 is less than, what is n value? 4. Is 0 is less than 4? Condition is true. If condition is true, now your control enters into this block. If ARR of I, ARR of 0 is double equal to key. In ARR of 0, what is the value we have? 33. Is 33 double equal to, what is the key element? Key element is 100. Is 33 double equal to 100? Condition is failed. So it is not going to enter into this if part. Next, I plus plus. Now I value is 1. Is 1 less than 4? Condition is true. If condition is true, again your control enters inside. Now if ARR of I, that is if ARR of 1. So what do we have in ARR of 1? We have 2. Now 2 is double equal to 100. The condition is failed. So again we increment I value. Now I value is 2. Is 2 is less than 4? Condition is true. Now if condition is true, again it is checking if ARR of 2. What is there in the ARR of 2? We have the element 56. Is 56 double equal to 100? No, condition is failed. Next, again increment I value. Now I value is 3. Is 3 less than 4? Condition is true. Now if ARR of 3, in ARR of 3 we have 8. Is 8 double equal to key? That is 8 double equal to 100? Condition is failed. Now increment I value by 1. Now what is I value? I value is 4. Is 4 less than 4? 4 less than 4? Condition is false. Then your control is coming here. Now what is the I value we have? 4. And what are the total number of elements we have? If I, the number of iterations, whatever have gone through, and if it is exactly equal to n, then I am giving this message, that is the given element is not there in the list because we have processed and we didn't enter into the key. This is the if part, we didn't enter, right? So if we enter into this, then immediately your control comes outside and gives the exact index of that particular element. So this is how we can search for a given element in the given list of array.